for the final exam. I have that, I think, pretty well prepared. Let me send that to you right away. Hold on. It'll take a minute. So can you guys go and check to see if you can see the review on eCampus? No. Okay, can you guys see it?
Not yet.
Yes, it's on. If you scroll all the way down on campus, it's on there. It's not like the same. It's like I guess like a multiple choice type thing.
Yeah.
Yes, we can see it.
Yeah, guys, it's not like a file.
I got it.
It's like a
Mhm.
yeah, it's like a multiple choice.
It's all the way on the bottom,
The bottom.
to the left.
Okay. So I'm going to if I can get this to you. All right, I think I was successful. See now, if you have an eCampus email message from me with it as well, along with an advice of when it's going to be. Can anybody tell me that?
Yeah, I got it.
You got it.
I got it as well.
Okay, good deal. So you guys are really ahead of the curve. Now let me tell you about a little bit about the exam. I've already completed most of the attendance, and then we're going to rush through tonight a little bit. Why? Because I need for you to be on track so that you can have enough time to do the final. So here's the plan. On Wednesday of this week, as I said, I sent you an email. It says that it's a very important class, didn't I?
Mm-hmm.
Yes.
And
Yes.
I will give you the review for the final exam. I'm not allowed to give you it to you like I did the midterm, but it'll be transparent to you what the difference is. To the faculty, they will notice a difference, and the difference is that your number one will not correlate to my number one. I mean, unless it's an accident. But your number one will correlate to one of my ones almost exactly. Does that make sense?
Yes.
Yes.
So you'll have to find the one that looks like it for the review.
I see. So on the review, Dr. Wickman, are we gonna work it out, or it's
I
just
am
choosing
going to
answer?
exactly on Wednesday. I'm going to work every one of your final exam problems out through the review.
Okay.
So there will be not a problem one that you should not know how to do, unless you just didn't take notes or you just didn't care or didn't attend. So that's why you should pass the word around. If you can put it out on Word, if anybody can do it on any kind of message systems you have, that is critical to attend the review Wednesday. Now, for those of you who have done extra things for the class, your grades will be bumped up for participation, and that's just justifiably so. Some of you all put a lot of extra effort in, like recording and so on. But I have no one that I know of in this group right now, on this call right now, that has less than an A. No one. So there are some folks that don't always attend, but they have the option, the video, and they'll be fine, most of them. So if you're worried about that, I will try to get those things posted soon. Some won't be there, but so some of you all are missing my homework still. So for example, Tamara, are you on? I'm missing yours.
I thought I had emailed that to you.
So I'm going to put here, if you'll send it to me again, I can get that, okay?
Okay.
Mariela Barrios, I'm missing yours. Jose Facundo, I'm missing yours. Mr. Green, I'm missing yours. Tiffany, I just got, I think. And Gerardo Ramos, I'm missing his. And April Sierra, I'm missing. Everybody else I have. So I'm going to try to nail these things down. If you don't see a grade in your eCampus for something that you think should be there, then you should contact me. And I will see once what I've missed. And I can go back because I do miss things sometimes. But I try not to. It's one of the most challenging things I have is finding the right person, because they might have an email that doesn't match their name. It might be like, Moondance 3 or something. I don't know. It's just kind of funny, but I don't know that. So are there any questions about the gradings?
No.
No.
What, you
No,
guys,
Dr. Whitman.
you should have some. For example, the final. The final will be done by a computer. On Wednesday, I will release the final exam. It's going to be electronic. The machine normally gives you 2 hours to do the 2-hour test. I'm giving you 6 hours. Now, that doesn't mean you got to plant yourself down for 6 hours. You can take a break and then re-sign in. But by noon on Sunday, I'm just going to be frank with you. Normally, if you take this final exam in class, you get 2 hours to do it, and I close the door and we're done. Most of the time. This one, you all will get to have as much time as you want up until Sunday at 12 o'clock noon. Does that sound fair?
Yes.
Yes.
Thank you.
Yes.
I got to turn your stuff in on Monday. So there'll be, I bet, 1 or 2 of you all, I'm hoping not though, that will not have this thing done by noon. So I'm putting down Sunday at noon that this test will be due. I think that's what, December 5th?
Yes, I think so.
So that means you have Wednesday night after this class to look at it if you want. You don't have to start it. You can just at least look at it. You have Thursday, you have Friday, you have Saturday. You can sleep on it Saturday and work on it Sunday morning. Excuse me. And you'll have until noon.
Bless you.
Thank you. So that's an unbelievable amount of time. Probably too much time, start to make you nervous. But I want to assure you that my goal is to have you feel very comfortable taking the final exam, not just in Word, but when you open it up, you're going to say, there's the problem. If you don't recognize the problem, go to your review until you see one that looks like it. Because my goal, believe it or not, I want to have good ratings from you all as well. My ratings right now, I barely have, I don't know, some folks said some good things, but the system, if you understand, Dallas College is in a unique revitalization process or unique retooling process. And as a result, professors like myself who really want to teach, they we want as many classes as we can get. Some teachers don't want to teach, as you probably know. They just want to do their minimum, get in and get out and be done. I enjoy it. So I need to try to have good ratings from you all. So that's my goal. And to do that, I want to give you the best of services possible that I can. I make mistakes. I do some things that I can do better, but I continue to work on them. But I think that the path that we're going on will be very good for you all. Now, in saying that, I'm going to start the class unless there are any questions about the exam. 33 questions. 6 hours is plenty to do it in. 2 hours is plenty to do it in, especially with the review. But 6 hours is more than enough. You can use your calculator. You can use your notes. You're not supposed to do it as a team. It's an individual thing. Any other thoughts or questions or concerns? You guys will be fine.
Are we required to have the lockdown?
You know, they wanted me to, and I said I didn't need it. I thought it's just too hard on folks. So I didn't do it. I didn't do the lockdown version of it. But they asked me, but I just didn't think it was necessary. Any other questions? I mean, I'm counting on your honesty. I'm counting on you to use your calculator. I'm counting on you to use your notes. And I'm counting on you not to, call, Lizeth or Angela or anybody else, Tamara, Sherry, to get the answer. I'm trusting you to just do it yourself. And they're just going to say, look at your, review. It's that one right there. Duh. And you'll be in good shape. So
I just emailed you the homework.
Oh, Tamara, you did?
Yeah.
Okay. So stick on me. If I don't mark it in, then jab me with the text. Get looking at that.
Okay.
All right. Okay, so we're going to head into the class then. Any other questions?
No, sir.
Just
No.
don't miss Wednesday. I took a couple students that I had in my other classes out for lunch today.
Dr. Wickman,
Yes.
on the final exam, I was having trouble with my microphone for some reason. Anyway, so we have to show our work?
No. Good question. And it will be just A, B, C, or D.
Okay.
And whatever you do, class, if you don't know it, don't leave it blank and say, Dr. Wick, I left it. Machine will show it. You didn't do it. Guess. You have at least, with the review, you should have at least a 50-50 chance, even if it's 4 questions. 2 of them are going to be way out there, not even close. All right. Again, I took a couple folks out that had helped me in some of my other classes today. Went to Red Lobster. It was kind of fun. And I hadn't been out for a long time. And you got 2 people sitting on a circular table in such a manner you're almost 6 foot apart. And it's kind of funny, but they serve you with masks and it's pretty cool. It's very different than before. I don't know, maybe some of you've been eating out or have ate out. It's it's very careful, and I hope that this pandemic, I got to get the shot, I guess. And if anybody's interested in the shot, my sons, both physicians, they advised me to get the Johnson and Johnson one, which requires only one shot, whereas the Madeira, Pfizer, all those others, the Merck, they require a shot and a booster. I'm lucky to just tell myself to get one shot. I'm not getting two. Holy cow. But maybe, it just depends. But anyway, that's the end of that story. All right, on to the class now. Let's see here. All right, so we're going to 9.7. I'm going to get into 9. Then I'll have to bring up the growth and decay model, page 655. Now, I want to warn you tonight, it's going to be a little bit painful. It'll be painful because we're covering a lot of stuff. I will try to minimize it to only stuff that you need to know, but there's a lot. In these last 4 chapters, like 7 or 8 of the questions on the exam, maybe more, are there. So you should be able to see the book now. Is that so?
Yes.
Yes, sir.
Okay. So this is a growth rate model problem for the population growth of Guyana. Now, all these things look unique to you, maybe. The first thing I would point out to you is that this arrow to the red is going up and is positive. That stands for a growth model, and that affects the K. It means the K is positive. Now, they want you to build the model based on the information that's given. Well, the growth function model is really in front of you. It's PO-EKT and K has to be greater than 0. Now, that's for growth. If K is less than 0, it's decay. That's all they're trying to say. So it's kind of confusing. K can be any number, but if it's growing, it has to be positive. Now, these are the questions, but let's go to the work so you can understand. All you're doing is going to plug in parts of the puzzle. Now, the book, I think this one explains it a little bit better than the other one. So look, the model says, and they have it here. Let's see. They do not. It's bad. They don't. So anyway, 25.2. That represents A to the O. Now, in the model, A to the O stands for the initial or first time that deals with this problem. The 0.0219, that's the percent of growth that's given to you. You see it in A. That goes where K is. That's the growth part. And notice 2.19% is always 0.0. 2 by itself is really 200%. They just show it as 2.19. I don't know. It's a math anomaly. But 2.19% is not 2 whole pizzas. It's 2/10 of a pizza. And so they show it read correctly. T is time. We don't know what that is. E is the Euler. That's Euler's law, and that's in your calculator. So look, they give you the problem, and they plug in all the parts of the puzzle. Let's go to B. Let's plug in B in our calculator and work it. So they say P of 5. That means T is 5. That's all it means. So we're going to put in 25.2 E to the 0.0219 times 5. And that's going to give us the answer. That's all you're going to do. Now, later on, we're going to do other things with manipulation, but all you're doing is plugging this in. And so the only question you probably have is, how do you get E? Well, we're going to go to our calculator and see. You'll have to do one kind of like this. So go to the calculator. Last time my calculator didn't work very well. I'm hoping it does today. I mean, now, it was earlier, it didn't work. So we're going to just do what the problem said. We're going to put in 25.2. Notice E is above ln here, so you got to do second, and then ln, which is really the E. Now, up there was the number 0.0219 times 5. We're going to push it out, and that's the answer by hitting enter. Boom. So it's going to be 28.11 something, and that's the number that you're looking for. Now, in algebra, you're supposed to know what that means. Well, we got the number right, but what does that mean? It's the population, and it's in millions. 28.1 something million. Now, they want to know if the population doubles, how long will it take? Well, look at C. Remember, AO, that's the initial amount, is 25.2. Excuse me. The population, that's P. We calculated with P of 5, you get 28. But they give it to you as 50.4 because it's double. You got to know double means twice 25.2. Everybody knows that. 2 times 3 is 6. It doubles. The question is, what is T? Now, C is a little bit different because you have a problem with the T being in the exponent. Well, your goal is to get T by itself. So you're going to try to shrink the right-hand side. So you're going to divide both sides by 25.2. That's going to make it look like this. Look at the left hand under algebraic solution. 25.2 divided by that gives you e to the 0.219t. On the left, you divide it by that, you get 2. Now look, step 3 is the critical one. You're going to take the log natural of 2. Why? Because the log natural on the left and the log natural, it brings ln and e cancel and brings down the t by the power rule. And it changes it to exponential form, so into regular form. So the exponent, when you take ln and e, comes down and they cancel. But the ln stays on the left because there's no e to cancel it. Now, to get t by itself, you simply divide the right by 0.0219. So you're going to take ln 2 divided by 0.0219. And if you do that, you're going to get about 3.7. So we're going to do that. All we're going to do is take ln divided by that. Simple. The math part is easy if you understand your calculator. So we'll clear that. We're going to look log natural, that's ln right there. And we said we're going to take 2. Close our parentheses, divide it by, and we said 0.0219. 0.0219. Boom. There it is. 31.65, and they rounded up to 31.7. Again, what is that 31.7? That's the interpretation you have to make. You did the math, and now as an algebra student, you're going to say, well, that 31.7 stands for time. That's years. And if the thing started in 2013, that was your original year for this formula. You add that to that number, and you get 2044.7. That's the year. If there are questions about this, this is the ln. Let's go on to the next thing. I'm only going to try to give you the problem that's close to the exam. This is close to the exam right here. All you're doing is plugging in and trying to get T. So look, the first thing is you can see, again, we did this already. You can see how they divided it. It looks like the same thing, but it's not quite because they're putting 40 in instead of 54 point something. Same rule applies. You're going to try to get the T by itself. So you're going to divide both sides by 25.2. Take log natural both sides. So now you have log natural 40 over 25.2 divided by 0.0219. It's a complex fraction. You're going to say, oh my goodness, this is different. It's nothing. It's the same thing. The calculator can do this. All you're doing the second last line, you're taking the log natural 40 at 25.2, dividing it by that, calculator do it. Let's just quick do it. Won't take any time at all since we got a good calculator. Okay, so we're going to take that number ln. It's 40. Let me start over. I'm going to start with parentheses. ln, because all this is going to be divided by another number. 40. Close parenthesis on this. Divide it by 25.2 because it's a complex fraction. Close that parenthesis. Now notice I have two open parentheses and two closed parentheses. So the calculator reads that as the numerator. Then I'm going to divide it by 0.0219. Nothing to it right there. Boom. Hit enter. There's your answer. I don't know. Is that right? Doesn't look right. 6.68. Is that what the book says? Approximately 7. Let's take a look again. See if we're right. No, we got 21. So something happened wrong. Oh, we inputted it wrong. My bad. Let's go back. Messed up. Sorry. Don't pay attention. Erase that real quick and try again. Log natural. This is where we have it. 40, my bad. Didn't need the parentheses on the outside. Divided by 25.2. There, now I close my parentheses. Now that's what I needed. I read it wrong, looked at it wrong, smelt it wrong, and then divided by 0.0219. And now that looks like the book. Should be right now. 21.097. There it is. So it read the top and then it read the bottom. So I had double parentheses in it, but I'm in the wrong place. So there you go. And we can check that. And there it is, 21. Let's go now. This problem number 2. I am not going to use the book method to do this because, let's see, let's take a look at the next page. Let's see. It says, suppose you have $2,000 invested in an interest rate of K, and it's compounded continuously and grows in 5 years. What is the interest rate? So let's take a look at what they do. I mean, we can do it their way. I mean, I just love to use the calculator. The other way, it's better. So they set it up. 2,000 e to the KT. 25,000 was the amount that it grew to. 2,000 would have started out to be. We don't know what the interest rate, that's K, that's the growth rate, but we know the time is 5. And they come up with 0.045. Now we can do this way by plugging it in, but, and this is not too hard to do, so we'll just leave it at that. But notice the second line, is no different than the first line. They just wrote 5K. But then they're trying to get the K by itself. So they divide both sides by 2,000. Now, in order to get the 5K to come down, this is exponent, you got to take log natural. Whenever you do the right, you got to do the left. So now I have log natural, 2504.6 divided by 2,000 divided by 5. And we'll make this simpler. We'll just do it. 2504.65. We'll use this method, even though I'm tempted to show you something else, but I'm not going to, because I'm not going to confuse you. We're going to divide it by 5. I'll do it on another one. Okay, so let's just do it. Again, calculator, back to that. Same thing. I'll let you see it both at the same time. So we're going to take log natural, 40. Did we do a, did I write it down wrong?
It's
Yes.
2,504.65 divided by 2,000, or is it
Yeah.
200?
It's divided by 5. Oh, 200, yeah. 2,000, yeah. So it's 2504.65
Yes.
divided by, this is all in the numerator. See, it didn't work that time. 2,000, sometimes it works. We're going to close our parentheses here, then divide it by 5. And we should get the answer. And the interest rate is about 0.045, which is 4.5%. So it works pretty good. Now, most of my other students I would try to teach, if we had more time, using the money function, but there'll be a time for that. So I think we've pretty much covered all this that I want to. Everything else is going to be the same. It'll be just like the calculator, like the test where you, and the review will show you this. This is a really cool thing though. Gosh, but this is not the problem I want to see if they got the, let's see if they have the medicine right here. Let's see. This is the same kind of problem, except for the K is not positive, it's negative. There's no other difference. Exactly the same problem. Exactly. Notice that the K is a negative number. All right. So that's that one. The one that I'd rather, the fish one is an interesting one, but let's see if we got here. I really would rather do the medical one, but they don't have it here. That's often used to teach. Okay, so look, this is the population. No, we don't want to do this one. I really don't want to do double count. Let's see if we got everything covered. But I think we do. I just like the fish one. Still looking here. This is really a cool problem. Look, a lake is stocked with 400 fish. the size of the lake, available food, and other things, make it so it cannot grow more than 2,500 fish. And believe it or not, like if you have a fish tank, fish will only grow as big as, and it just depends on a lot of factors. So the population gets closer and closer to this limiting value, but never reaches it. The population of new variety of fish in the lake after time in month is given by this function. So they give you this formula. So now that you have the formula, they're going to ask you some questions. Again, the numerator is the limit of the amount of fish that can go in this lake. Can never surpass that. And then the rest is the formula, and P of T stands for the population of the fish in this lake over T, which is time, or based on T, which is time. Now notice that in the denominator, you have a negative K, but be very aware that you have a negative in the denominator is really, once it's pushed up, you cannot have a negative K or exponent, so it really is a positive number. It just looks negative in the denominator, and it is negative, but when it moves to the numerator, it becomes positive. So look. So here's the question. This is almost exactly like this. If you push 10 into that equation, you're going to get 2,059. So let's just do that one number, and then I'll make my point. Let's go back. Let's look at the equation. So T is 10. So that means in the numerator you have 2,500. Denominator you have 1 plus 5.25 e to the negative 0.32 times 10. So the only thing you're going to put in there is 10 in the T. And so the only problem that students have is how do you put it in your calculator? So that's what I want to do. Just to show you. See if I can. All right, so here we go. Clear this all out. So our numerator is clearly 2,500. We don't need to do anything more about that. And this is divided by, and we have 1, 4, 5, I think that's right, 0.25 E, so E is second, ln, and we have up there a negative, that's the sign right here, negative 0.32, I think that's right, times 10. Push it out of that, and we should be able to hit enter and get our number. And that didn't work.
I think it's 1 plus 5.25 E.
So it's 2,500. Let me get that correct number because
Yes.
I might have wrote it down. Divided
It's
by
1 plus 5.25.
oh, it's 1. It's they got to use parentheses in 1. Yeah, that's right. I thought, yeah, my plus was a 4. 5 point. Thank you. 2.5. Don't let me do that again. And then the Euler, second E, and then we're going to put negative 0.32 times 10. Push it out of that, close parentheses, and hit enter. 2,059. That's exactly right. I just put the wrong number. I read my 4 to be or a plus sign to be a 4. So, but now here is the key. This is how many fish are going to be after 10 years in the pond. Now here's the neat part about this. If you think about it. The point. The point is this. After 10 years, you saw the answer. It became 2,059. At 20 years, it becomes 2,478. At 30 years, what will the population be? Anybody?
2,478.
No, 30 years. What will it be in 30 years?
Oh, 30.
No math needed. What will it be? This is the algebra brain part. It will never be more than 2,500. It can't.
45.
2,500. That's the most it can be because what it says, it has a limiting population. The fish can never go beyond 2,500. And that's what this green line shows. This is called a horizontal asymptote. It means that you can never get any more than 2,500 fish in it. Anyway, that's that one. All right, now we got to go to the next chapter. The next chapter is going to be 12.1. Anybody have that page number?
Yes, it's 771.
Very good. Getting there right away. Now, I'm going to go fairly fast on these because I'm only going to cover those things that you need to know. So look, this is an arithmetic sequence. And they say the first term of the sequence is donated, they could say designated, but they say it's denoted as a to the 1. The second term is a to the 2, and so on. The equation says you're going to start out with -1, and then you put n, that's the first number, and that's going to be 1. The only thing that changes in this whole equation is the n's. And the n is whatever it tells you. If the n is 1, then look, you get a -1. N is 2, you get 4. N is 3, you get -9. You can put it in your calculator. A -1 to the cube is a -1. 3 squared is 9, so you get a -9. -4 is going to be even. 4 2 is 16, and so on. So this is simply a matter of reading the equation and plugging in the number for n. Let's go to the next one. There was nothing mathematically about it hard other than plugging it in. Now, they want you to look at this equation and predict the next term. Let's go to C, start out easier. 2, 4, 8, after 8 comes what? 16 and 32, it doubles. Look at A now. Maybe it'll make more sense. 1, you take the square root of 1, you get 1. Take the square root of 2, you get square root of 2. Square root of 3, you get square root of 3. Square root of 4, you get 2. The next one will be square root of 5. Then the square root of 6, square root of 7. So all that is just an exercise. For this, example 3, I mean, this is grade school stuff. Example 3 says, find S sub 1. That's the first one, that's -2. Then it says S sub 4. When you look at S sub 4, what do you get? Well, it tells you that you're adding up the first 4 terms. So you're going to take -2. S stands for the sum. The sum of the first one is going to give you the first answer. It's -2. S sub 2 was going to give you 2 because you add up the first 2. 4 minus 2 is 2. S sub 3 is going to be a -2. A -4 rather. Because -2 and -6, -8 plus 4. S sub 4 means you add up the first 4 terms. So you got 8 and 4 is 12. Minus 8, you get what? 4. So all you got to do is follow the directions. The sum of the first 4, the sum of the first 5. Very simple. Again, you won't even have anything on the test like that, but it's something you should know how to read. S stands for sum. Uh-oh. I don't see anything here. 73. Could be a lockup situation. There it is. That's all. Okay, now, this is, did we miss a whole bunch of stuff here? Summation notation, we did. We got to have this because this is on the test. See if we get us there. It won't let us open it. There it is. Sigma notation. We're going to do a couple of these on the calculator. Now let's look at A. Have you guys had this with me before, any of this?
No.
No, sir.
I want you guys to see how easy this is. It looks weird. It looks different. Look at A. A says you have K equals 1. That means this equation starts with 1. It ends with 5. And it says you're going to add them all up. So that means you're going to have 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed all the way up, and you add them. Now, this is, you can see manually they did it. But we do not want to use our calculator, our manual stuff to do any of these. We're going to go to our calculator. You can see they got 225. Calculator is going to be 1,000 times easier, especially for test stuff. So we're going to go to summation notation. We're going to go to math. Now, if you go to math, you're going to say it's not there, Dr. Wick. Well, it's the 10th one, but they have it marked as 0. There it is, summation notation. Hit enter, boom. There it is. Now let's do second quit again. Now let's just go to math. Again, you don't see it. I said it's 10, but they show it as 0. So I just plug in 0, boom, it shows up. Now we don't have A in the calculator, but we have X. So we're gonna hit X. We know our X is going to start with number 1 because that's what it said. 1. And we said it's going to go up to what? Okay, 1. My bad. It's going to go up to, we said what? 5?
Yes.
Okay. So help me out with this. I'm going to put 5 up there. Now in the expression, what did they have inside there?
I think it was K3.
K to the 3, but we don't have a K, so we've got to use X. And it's going to be the third power, so we'll put 3 there. And push it out. So this is exactly what the problem says. So we just hit enter, we'll get the number, 225. So you have to remember to do that. Now they're going to give you a couple to do. We can do this more complicated one. We could do B. B is much harder to do. It's probably harder to do than a C, but C is in the hardest position. Which one would you guys like? I'll do one more for you all. Which one would you like? Pick someone. Pick.
C.
Okay, C. So it's going to start. It says I equals 8, so we know X is going to 8, and it's going to go to 11. The 2 plus 1 over is the expression. This part here in parentheses is called the expression. So this will be not hard to do. We're just going to go stop. We're going to go to our calculator and put it in. We'll clear it. We know it's under math, and we know it's the 10th one or 0, so we hit that, boom. We know we don't have A in this case, or I, we have X. We're going to put X. We know in this case it says it's going to start out at 8. It said so. It says it wants us to go up to 11, so we're going to put in 11. Inside the expression, it says it wants us to do 2 plus 1 divided by our X. Now close the parentheses, get out of it, and hit enter. I don't know, that didn't look like the right answer. But let's see.
I think it was a negative.
What
Oh
was
no,
the
that
next?
was B. I'm sorry, that was B.
See what we have. Let's see. Yeah, that's right. 8 and 1691. That's it. Exactly what we had a fraction. And it's 8 point something. That was did it perfectly. Okay, now the next thing is they want to do a signal notation. You'll never have to do that. But you can see that the number you have 1, 2, 3, 4, 5, 7 expressions. So it starts from 1 and goes to something. And what do? They squared everything. Let's see what they did. So for the first one, it starts. It says starts at 0. It goes to 6 because you have 1, 2, 3, 4, 5. Actually, you have 7 expressions there. 0 counts as 1 to 6, so that's 7. And 2 to the k. Again, you'll never have to do any of these, but it's good to see how they started out. 0 to the 0 power, anything to the 0 power is 1, and so on. 0 to the 1 power. Okay. Let's go on to the next. Find the first 5 terms of the sequence defined as a to the 1. All you're doing in this particular problem, this is a recursion formula. This means you start out with 5. If they want you to find the first 5 terms, they give you the first one, so you only really got to find 4. So 5 is your first term, then you plug it in. 2 times 5 is 10. Minus 3 gives you 7. Then you plug that in. 2 times 7 is 14, minus 3 is 11. Then you plug that in. That's what a recursion formula is. On the test, I don't think you'll have one of these, but you should know it. I mean, you should know how, I mean, this is just too simple to do. All it means is after you get your answer, you plug that in for your x. You get your answer again, plug that in. Let's go to the next one. Trying to find the ones. Okay, we're going to go to the next section. We're going to do 12.2. Anybody got that page?
That's on page 777.
Okay, thank you. Arithmetic sequences. Now, in arithmetic sequence, you got to find the D or difference between the second and the first. Notice an A, in this problem, that's all you're finding is the D or difference. In order for it to be an arithmetic sequence, it has to be the same. So you can take 14 minus 9, it's going to be 5. 19 minus 14 is 5. 24 minus 19, 5. In every one of these problems, it's going to be the same. Common D 5, common D negative 7, common D 1/2. That's all they want you to do is find the difference. Not hard. All right, so now look. Look at example number 2. You will have one of these on the exam. It says it wants you to find the 14th term of the sequence. Again, I want to assure you this is easy. A to the 1 is the first term in the sequence. They give you the sequence, 4, 7, 10, 13. They tell you they want you to find the nth term. The nth term is the 14th term. Now, you know the difference between 4 and 7 is 3. The difference between 7 and 3 or 10 is 3. 13 and 10 is 3. So all you're going to do, look at line 2. Plug it in and get the answer. 4 is the first term. That's A to the 1. 14 minus 1, because that's a term, is 13. 13 times 3, that's a D. It's 13 times 39 plus 4 is 43. Boom. Example 3, they're doing it in reverse. They're telling you that you have the 301st term. They want to know what the n is. Well, A is already 4. 3 is 3. That's the D. So you multiply 3 times n, you get 3n. 3 times n gives you -3. You have the third line. This is grade school stuff. The third line, you're just trying to get n by itself. 4 minus 3 is 1. You subtract 1 from both sides, you get 300 equals 3n. 100 equals n. Boom. So 301, which was what you're trying to figure out what term it was in the sequence, is the 100th term. I'm not going to do any more of those. They're too simple. I mean, you're going to say they're simple for you, Dr. Wick, but what I'm saying is, if someone shows you how to do it, you're good. And you can fill in the parts. You won't have any issues with that. Now, this is the same sort of thing you use in summation notation. Find the sum of the first 100 natural numbers. That means you're adding 1, 2, 3, all the way up to 100. So there's a formula. The formula is S sub n. That means the sum of all the numbers. N is the number of numbers you're adding up over 2. A to the 1 is the first term. And A to the n is the last term. Again, you just plug in the parts of the puzzle. You got to know n is what? The terms. A to the 1 is the first term. A to the n is the 100th term. You plug them in, you get 50 times 101, which is 550. So the sum of all the numbers starting with 1 through 100, natural numbers, is 550. So, number 6. We have 6 is the classic one. 6 I will end with for this. 6 is the test question. You have to do 2 parts. The first part is they tell you that they want you to find the sum of the first 15 parts of this sequence. But for the equation, look, you don't have all the parts. A to the 1 plus A to the n. So you've got to find out what the last term is. That means you got to use the formula up above. So the first formula they give you is how you get the total of the first 15 terms. You know n is 15. You know a to the 1 is 4. But what you don't know is a to the n. So you're missing 2 parts of the puzzle. But we can find that last term, a to the n. A to the n equals 4. That's plus 15 minus 1 times 3. 4 again was the first term. The way you find that term is 15 minus 1. The D was 3. Look at the red on the right. It says substituting into the formula. The nth term is found by taking the first one plus, open parentheses, n in this case, 15 minus 1 times the D. So look at that little red formula there. That gives you the last term, the 15th term. Now, we have a to the 1, which is 4. We have 46, which is the a to the n. We have 15 over 2. We multiply it out, and boom, get 375 for the answer. So 6, you need to study because that will be on the exam, number 6. Dr. Wickman? Let's see. Okay, guys, I need to do this. Edward, this is Dr. Wickman. I'm on a conference right now. Can I give you my number to call back? 214-808-7728. All right. I guess that didn't work. Again, number 7, I'm not going to waste your time. We already know how to do that. Does anybody want me to do number 7 again? Anybody? I'll do it if you want.
Okay.
You want me to do it?
Yes.
Okay, so we're going to use our calculator. We know we do not have K, we have X's. All right, so go to our calculator, boom. It already fell asleep on me. We're going to go to the summation. We know it's under math. We know it's the 10th one or 0. We're going to go down there. After 9, show to 0, enter. Now we know we're going to start with no A, it's going to be an X. It's going to start with number 1. And we're going to go up to number 130 and adding them all up. We know our expression is 4K plus 5. So we're going to put in, but we don't have K, we have X is 4X then, plus 5. We're going to close our parentheses, get out of it. Oh, back up. Jeez. Wait a second. Get out of that. And hit enter. 34,710. Just that simple. Let's see if we did it right. Let's see. I didn't look at it real close. I should have probably paid more attention. But what did they come up with? Did I write it down wrong? Plus 5, 130, 4K. Let's see. Helpful to write out a few times. 80, 525, 30 over 2, 34,710. Is that what we got? 34,710?
Yes.
So we're good. All right, so we're not going to do any more of this. Let's go to the next chapter. What's that? Geometric sequences?
It's on page 785.
Okay, 785. I told you guys you're going to get sick tonight, but I have to do this. A geometric sequence. Remember in arithmetic sequence, you took the number and subtracted. Now in a geometric, you take the ratio. So 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So a geometric sequence is a ratio. And that's example 1. That's all they did was show you the ratios. Take the second one divided by the first. Next one. Example 2. It says here, find the 7th term of the geometric 420, 100, so on. So first we note that a to the 1 is 4. The ratio, 20 over 4, is 5. So we're going to plug it into the formula. Formula says a to the 1 is 4. You have 5 is the D, or the ratio. And they want the 7th term, and it's the formula says you take 7 minus 1. So you simply take 4 times 5 times to the 6th power, which gives you 62,500. Again, you have 4 times 5 to the 6th. There it is, 62,000. I just have to put it in your calculator. And then you can say, well, it's easy now. How do I do that? What was the problem? I mean, how do you know to do that? Well, just follow the directions. We knew how to create the R. The formula is right there. It says right there. Using the formula, a to the 1, r to n minus 1, you get it. The first number in the equation or sequence starts out as 4, so that's a to the 1, 4. R, we calculate that as 20 over, which is 5. Seventh number we want to find, 7 minus 1 gives you 6. Boom. Find the 10th term of this sequence. Well, you're going to put in 64, the first one. 32 and 64 gives you a ratio of a negative 1/2. Remember, it's the second one divided by the first. Look at right there. 32. So all the parts of the puzzle are there. A164. You want to find the 10th term. Ratio is this. And negative 32 over 64 reduces to negative 1/2. So again, 64 the first term. Negative 1/2. 10 minus 1 is 9. Boom, I can put it in the calculator again. You're going to get the same thing. In fact, I'll do that one more time. I'm going to take 64 times, parentheses, a negative 1/2 to the 9th. And we'll see what that gives us. (64) times, we use parentheses, negative 1 divided by 2. Close our parentheses. I think that was to the 9th power. And hit enter. A negative 0.125, you can say, well, that doesn't match. Well, we can make it match. Go to math, hit fraction. And there it is, negative 1/8. Remember, if you get a decimal, don't panic. Just go to math. And we can make it go back to decimal. There it goes back. So it's no problem. Your calculator will do everything. Let's go back to this. Now, there's only one other thing in this that I want you to know about, which is on the test. We've already done example 4. We just have used the summation notation. You could use the same thing here, but on the test, you're just plugging in the numbers here for 4. So it's no different. But what you haven't done is that sometimes you can add up an infinite geometric series. This is on the test. Now, I like this better. This says you can find the total sum of a sequence, even though it has ... behind it. You can add it up and get an answer if the ratio is less than 1. So the sum of an infinite series equals a to the 1 over 1 minus r. So let's just do 1 because that's what you're going to have on the test. It's not hard. Again, this is not hard if someone just explains it to you. So the example A is going to be a no bueno. Yeah, you have 3 plus 1. So the ratio is a negative 4/3, or so it's not going to have because it's greater than 1. The r is greater than 1. 3 divided by 1 is 3, and 3 is not less than 1. It says so in A. But let's take the next one. You have 1 divided by negative. That's a negative 1/2. That is less than 1. So how do you do it? Very simple. The formula is right there under B. Take the first term, that's on top, negative 2. And it's divided by 1 minus 1/2. That's a negative 2 over 3/2. And that gives you a negative 4/3. Now, let me do this manually for you. There's no way you cannot know how to put these numbers in. R, again, you take the second number and divide it by the first. That's how they got negative 1/2. They don't show you, but I'm helping you. Take the second number And it would still be the same thing. You could take the third number, divide it by the next one. You can't go wrong. Take negative 1/2, divide by 1, you get negative 1/2. The question is the math part now. To do it manually, which you could do, I mean, look at my notes. I thought I had it right in front of me here. Does anybody remember that ratio? It's in my notes, but I just need to go back. Was it negative 1/2 over what? Negative 2 over 3/2. That's what it was. Hope you're paying attention. Negative 2 over 3/2. Now, in order to solve this complex problem, you've got to multiply the bottom by the reciprocal. Why? Because it gives you 1 then. It gives you 6 over 6. Whatever you do the bottom, you got to do the top, which gives you a negative 4/3. So that's the answer there. Let's go back. Check it out. So we took the negative 2 divided by 3/2, we got negative 4/3. Now, if you didn't like this, you could simply do it with the calculator again. I mean, it's just so simple. Calculator. Turn it on. You're going to take a negative 2. Let's go on. Negative 2 divided by 3/2. 3 divided by 2, close parentheses, and boom. Oh, it's that same thing. We don't like that. We're going to do math, enter, enter. We'll get negative 4/3, just like our answer. That's what you have on the test. Go to the next thing. Number 7 is interesting. And you know, a lot of students have trouble with it, but it's just find the fractional notation for this. Well, that's 0.78, repetition, because it goes on and on and on. So it really is 0.78 plus 0.0078 plus 0.0078. That's what it is. So the first term in the sequence is 0.78. Now the ratio is you take one and divide it by the other. 0.78, the first one. 0.0078 divided by 0.78 is really 0.01. That's the second term, 0.0078 divided by 0.78. It's this. Point 0.0078 divided by 0.78. Yeah. We can put this in our calculator. If you don't want to do it by moving the decimals over. Most students would prefer that. So that's what we'll do. 0.0078 divided by 0.78. And we should get exactly that, 0.01. Oh, correction. I put in the wrong, I don't know how to do that.
78.
Yeah. 0.78, yes. There it is, 0.01. And, you know, it always is important to put in the right stuff. Thank you guys for your patience. Okay. Now, Back to the problem then. Now that we know the first term is 0.78, you know the R is 0.01, you have 0.78 over 0.99, which gives you 26 over 33. So that means that is what you would get if you added that up. Last problems. We are going to go on. Oh, no, I got to do this one. I've done this problem, by the way. I always ask students before I do this problem. I said, I have a ranch. I have several of them. I said, if I asked you to come and work on my ranch for 30 days, and I started out you at a penny a day and doubled your salary for 30 days, would you do it? Everyone, without exception, except for those individuals that have not looked at the book, those that have looked at the book will say, are you kidding? I would never work for a penny a day. But here's what happens. In fact, by the end of the class, everybody wants to range. Yeah, at the end of the first day, you get a penny. The next day, you get 2 pennies. The next day, you get 4 pennies. But look what happens. The summation of this, the first one is a to the 1 is 1 penny. The formula says you take 1 minus the ratio. The ratio is 2. You take the second, divide it by the first. Remember, it's 2 cents divided by 1 cent. That's 0.02 or 0.0. That gives you 2. And then it's for 30 days. Well, 30 days is R to the N. So in putting this in our calculator, 0.01 cents for the first day, 1 minus 2 to the 30th, all over 1 minus 2. Most people know that's a minus 1. I'll just do that. So everybody agree the denominator 1 minus 2? So let's go to our calculator again. So again, I'm going to put in 0.01. That's a penny for the first day. And then the formula says 1 minus 2. The upper arrow is 30 because that represents 30 days. Push it out of that. Close our parenthesis. And divide all this by 1 minus 2, which is a negative 1. Hit enter. And you'd make $10,737,418.23. And most people say, Doctor, I had no idea. I had no idea we'd be making that much money. So you can always try that trick on someone and it'd be pretty good. Last one, I want to do 2 problems yet. The binomial, 12.7. Anybody have that page number?
Page 814.
814. Was that Lizette?
Yes.
All right. So let's go to 814. Pascal's triangle. I'm going to show you a couple things. We will work 2 problems only. This is Pascal's triangle. Notice the pattern. Anything to the 0 power is 1. A plus b to the 1 gives you a plus b. 2 gives you that. Notice the pattern. The pattern is right here. 1, 1, 1, 1, 2, 1, 1 through 1. And you add the top numbers to get these. It's pretty cool. Now, the test problem. They're going to ask you to do, they're using the, we don't want to do this one. Let's see which one. We don't want to use Pascal's triangle for it. I guess they are using all of Pascal's triangle instead of the other theory. Okay, so look. Let's look at number 2. I really don't like number 2. Let's go back to number 1. Maybe that'll be better. Because it represents closer what's on the exam and really what you need to know. Okay, yes, let's do this one. If you look at Pascal's triangle, this is the 5th exponent. So if we look down, 1, 2, 3, 4, 5, you get the pattern 1, 5, 10, 10, 5, 1. That's the expansion of the CRC. That is the combination that this book doesn't teach. They just use the triangle, which is fine. So looking at this, the A term is the U. It's the first term in the expression. The B term is the second one. That's the negative B. The N term is the exponent. That's 5. And then they use the 6 row but it's with the 5s in it, the 1, 5, 10, 10, 5 rule to expand this. So in the solution, the thing that you should note is how they get the A, the first term inside the parentheses, how they get the B, the second term in the parentheses, how they get the N. Now they're going to use the formula and use Pascal's triangle. In the formula that is normally used, they don't use Pascal's triangle. There's another mathematical method, but this is better. It's easier because you choose the triangle. So if you 5, you use 6. Okay, now then you just plug it in. 1, first term is u to the 5th. Then 5 u to the 4th. Now, the formula set, gosh, it's not very clear. But notice that they don't show the formula here. U to the 5 is here, is the A term. The B term is negative B to the 0, but it's 1, so there's no negative V here. Look at the second part of this, the 5. Notice look at the pattern. Instead of U5, now you have U4. Don't look at the next part. Look at 10 now, U3. Then look at the next part, 10, U2. Then 5, U1. And then 1, and it's gone. Look at the second part of the pattern. The first part is the B, and it's not there because it's to the 0. Then you have negative B to the 1. Then you have negative B to the 2. Then negative B to the 3. Negative B to the 4, and negative B to the 5. Then you multiply it out. 1 times U is U. Negative 5 times U is this. 10, so on. This is what you have to just look at the pattern and understand. So that's that one. Let's see. I might show you. Let's see. This is the pattern that is normally used. Let's go to the one that's going to be on the test. We can expand this, but I just want to show you one part of this. Notice after the equal sign, you have 5 over 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. The 5 over the 0 is 5 factorial over 0 factorial, which is 1. 5 over 1 gives you 5, and so on. It's just like the Pascal's triangle. Now, if you didn't know that, using they're not showing you a formula here. They're simply showing you a pattern. All the tops are 5s in the parentheses, and all the bottoms move up. 0, 1, 2, 3, 4, 5. Now, those turn into numbers. How do they get the numbers? Let's go to our calculator. Let's do so we have What I'm talking about in parentheses is like 5 over 0, 5 over 1, 5 over 2. The pattern goes on and on until you get 5 over 5. Now, the number, let's do this one, 5 over 3. How do you get the answer for that? Well, there's an elongated way to do it, but there's an easy way. We're going to erase this. We said we're going to do 5 over 3. We're going to go to our calculator. We're going to go to, let's see, on, clear. Let's see if it's under stat. Calculate. Nope. Let's see, math. Yeah, probability. Yes, it's number 3. It's under math and then probability. And we said we put in 5, 3. So we're going to put 5, 3, and it's going to give us the answer. And we know, of course, what, 3, come on. Answer. 10. We knew it was 10 because of Pascal's triangle. Okay, so number 3 is an example of expanding this out. This is the one you got to know how to do, but not the test question. You should use number 3 to study, to see once how they get there. This is the one you need to study. Now, on the test, we're going to do find the specific term. This is the one you have to do. So, we're going to do number 5. Number 5 says, and above it is the formula. It says to find the 5th term in this expansion. So we have the formula above us right there, n over k, a to the n minus k, and b to the k. A, we already said that A is the 2x. We said B was the negative 5y. That's this part. The n is 6. And the k is always going to be 1 less than the number you're trying to find. If you're trying to find the 5th term, it's going to be a 4. So all the parts of the puzzle are easy except for maybe understanding the k. The k is always going to be less by 1 the term you're trying to find. So if you follow the formula, it says the first part in parentheses is you have 6 over 4. That's n. Remember it says n. N we said was 6. That's the exponent sitting right there, 6 over 4. So let's figure out what number that is, 6 over 4. We go to our calculator. We're going to take math over probability, hit number 3, put in 6, and push over to 4, and hit enter. I got to get out of that first and then hit enter. You get 15. So we know that that number is 15. That's 6 over 4 is equal to 15. So we go back and plug it into our formula. And they don't even show that number yet. They just put 6, but believe me, it's 15. And then they say, the next part of this is the 2x, the 6 minus 4. And we know 6 minus 4 gives us a 2. So look after the or. It's 2x to the squared. And then we know it's negative 5 to the 4th. So let me write this out so you can see exactly what I'm saying here. Because it's a little confusing. I'm sure you're going to say it's confusing, but I'm going to try to make it so it's not. So look at our line here. Our first line starts at 6/4. I'm going to change that to 15. Then I put everything else there. 2x, 6 to the 2, minus 5y to the 4th. I'm going to write that down. This is what you're seeing. First of all, you're seeing is this. 6/4. 2x squared minus 5y to the 4th. Now we know this is 15. 2 squared is 4, x squared like that. Negative 5 to the 4th power is a positive number. 5 times 5 is 25, times 5 is 125, times 5 is 6 what? Does anybody know? What's negative 5 to the 4th power?
-20.
Did you say -5 to the 4th power?
No, yes, that's correct.
Negative 625?
No, it'd be positive. 625. Because it's to the 4th power. Negative times negative is a positive, and so on. So now you have 15 times 4 times 625 x squared y to the 4th. So if you put in your calculator, 15 times 4 times 625, can somebody give me that number? No?
37,500?
Yes.
So that's your answer. 37,500 x squared x to the y to the 4th. Let's take a look. I'm pretty sure that's right. It's too tiring to 37,500 x squared y to the 4th. Number 5 on the exam. Practice it. And that's it for today. It's a lot of stuff, class. I know it. I wanted to get you through this. I wanted to make sure Wednesday you will be there. Let me check to see. I know we've lost a lot of folks, but have we gained anybody new that hadn't been on her earlier?
No.
Well, let me say thank you for sticking with me. And say good night. Or any final questions? You guys know to be here Wednesday. I would not miss that class for anything. It's the final. You know, the final counts 40% of your entire grade, but you all in this group here, you'll be fine. Sherry, any questions?
Thank you,
Yes.
Dr. Rickman.
Thank
No,
you.
Good night.
When you've
Good
shown
night.
us how to put it under probability, I was having a little problem to see how you put the I think 6-4 in.
Yes, no problem. What you do is this, Sherry. You we're going to go back to our calculator.
Okay.